little understanding of history as well. Okay, so coming to the history, there was a guy called Duck Cutting. He was a freelancer. In 2002 to 2003, he was doing some project called Nutch, Nutch, Nutch. The project is kind of a web search engine project, and he started as a freelancing. And when he was doing some research on that project, he found some issue. The issue is the big data. I mean, he's getting the huge amount of the data, and he's getting the different kind of data, and he started facing that issue. So then he was doing research on that in the 2003, I mean mid of the 2003 or 2014. The Google has launched something called GFS. You guys can able to see here. The Google launched something called GFS. That that GFS is this is a GFS. GFS is Google File System, and they have launched it's an abstraction. This is just an abstraction. They have not really not given any, they have not really given. Sorry, guys. They have not really given the source code. Then these guys have started doing, where I want to change my pen. I'm not able to do this. So they started the GFS and something called MapReduce. These are white papers. Those are white papers. So white paper means they just give an abstraction. They just give an idea, and this is how we can manage it. This is how we can do it. And 2004, the Duck Cutting who implemented that paper and in the distributed manner. It's called distributed file system, and he has also implemented the MapReduce framework for his Nudge project. And the problem has solved in that time, but still he was doing a research on it. In the 2006, he joined to he joined with Yahoo. Yahoo has hired him along with his Nudge project, and they started doing more research on the Nudge project. So when they're doing a research on this Nudge project, they have they have what to say, they skip testing with the Nudge project by giving a huge amount of the data in the different machines, and the Nudge project has become Hadoop. The Nudge project has become Hadoop. So the origin of the Hadoop is Nudge, and this has been developed at Yahoo, and they have tested at in the New York Times, which is 4 TB of their images. They have converted in. They have archived using 100 EC2. EC2 is nothing but Elastic Cloud Compute. Elastic Cloud Compute. Elastic Cloud Compute means nothing but on a cloud services, where you can get the machines, where you will rent the machines from the cloud. So to tell in a simple way, where you will rent the machines from the cloud, and it is automatically scaled. Today you want 3 machines, and the next half an hour you said I want 10 machines. So it can easily scale, right? So it is, they have tested with that. They got a very good results, and in 2006 itself they have released it as Apache Hadoop. Okay, in the 2006 itself they have released it as Apache Hadoop, and they have tested with this New York Times. After testing it, and they were keep doing some research on that. And 2008, there was Facebook also taken the source code from the Hadoop, and they also found something called interesting. They're also facing some problem with their data processing. They used to process a huge amount of data using SQL. They used to write a very big scripts, and they used to write a huge number of queries, and they found this distributed manner is little interesting. So distributed manner means how we can store the data into multiple machine, how can we process the same data into in the multiple machines parallelly. So that idea is really interesting. So they also started contributing with Apache, and they also launched something called Hive. So they have designed a tool called Hive, and they have donated to Apache. The same year they have tested another sorting algorithm, I mean another sort, which they have sorted 1 TB of data, and they have sorted in 3.5 minutes. So in 10 machines. So it is like these are also EC2s, like I can say these are also 910 data nodes. They have launched a sort algorithm on 1 TB data. So it took 3.5 minutes of time to sort, because why they have chosen the sort, that is a competition. Like if any framework comes and they want to prove it is very fast, and they will be doing this sort algorithm. Even Spark has the same thing. So Spark has become no they have cracked the world famous they become world famous when they compared with MapReduce. So we'll talk about that later. So they have sorted the 1 TB of data in 3 minutes in the 910 minutes, 911 nodes, I can say, machines. And in 2008 itself, there has been Cloudera has been founded. Why the Cloudera has been founded? Because the Hadoop is it's a open source, so anyone can take a code and they can customize it. Anyone can take a code and they can customize it because it's open source. And the Cloudera has been founded, and they have taken the code from the Apache, and they have did some cosmetic changes, and they have given customized the product. And they have then in 2009 they have sorted again a TB of data in 62 seconds over no these many nodes, close to 1500 of nodes, and sorted the petabytes of the data into no 16 hours. And at the same time, they have also a Hadoop summit, and they have conducted Hadoop summit, and there are so many contributors start looking at this Hadoop projects, because the Hadoop projects become very famous, and everyone start looking at that, and it become very top projects in the Apache. And Doug Cutting is joined Cloudera, and he started serving with the Cloudera. So that's a little history. And coming to the naming, how they have named it as a Hadoop, there is no specific reason for it. And when they have designed the project, when they found the project, I mean when they found some kind of software, then they want to name it. So they are thinking about getting the name, but 3 years or 4 years of old duck cutting son, he was playing with a toy elephant toy, the small elephant toy. And you guys can see in this screen, in this screen, so yellow elephant, small toy, soft toy. And he used to call the toy with a Hadoop. It's like Hadoop, like he used to call a Hadoop, and they have liked the name, and they have named it as a Hadoop. So there is this is a very silly reason. I mean, there are no specific reason to name it. Okay, and it is not Hadoop. Actually, it should pronounce as a Hadoop, like SAP. And but it's a due to the long spelling, so we have started calling as a Hadoop. So this is the little history about uh, the brief history about Hadoop. Okay, the origin of the Hadoop, I can say it is Nudge. So initially it was a Google file system. The Google file system became a Hdfs, and MapReduce remain MapReduce. The MapReduce remain MapReduce. Right? That's a little history about it. Let's go ahead and see how the real-time cluster looks. We will see the real-time cluster, how the architecture and how it looks. And I'm skipping all these
Yeah,
things.
Ravi.
Yeah.
Ravi, I have a query. Like you mentioned that till 2008, 2009, it was all Apache and open source, and that then Cloudera took over because no one can use it, all the
No,
library.
it is not like that.
Right now,
No, there is. It is still available with Apache, and Cloudera has taken the source code. It means it's not take over. It means that the source code is still available with the Apache, and they have taken I mean, they can download the source code, right? They can take the source code. If it's open source, you can download the source code yourself as well. So they have taken the source code and they have improved it. The Cloudera has been Cloudera, Hortonworks, Mapper. All these guys are what they have done. They have contributed with with the Hadoop, and they have taken the source code and they have built it on top of it. Still, your Apache Hadoop is exist. Your Cloudera Hadoop is exist, as well as your Hortonworks, Mapper, EMR, and all are also exist.
okay, all right, thank you.
Yeah. Okay, it's a open source, and this has a specific features. We will talk about each and every feature now. Oh, 1 minute, guys. I'm just getting. Okay, sorry, guys. So this is the some of the features of Hadoop, and we have already seen this feature. So sometime some other session. It's a cost-effective, large cluster, parallel processing, distributed, automatic failure management, and so it has a data locality, heterogeneous cluster, and a scalability, right? So it has its no very good features of Hadoop in and what makes Hadoop really useful, it's easy to scale, and it is economical, economical, I can say, like less cost. So you don't need to spend, a huge amount of the money for the setting up all these things, and it's efficient and reliable, and it's open source. And these are the distributions. Not only these, there are so many other distributions. Even Intel, what you call, Intel has their own Hadoop, and Microsoft has its own Hadoop, Amazon has its own Hadoop, right? So there are so many. They are coming up with their, IBM has their own Hadoop. So the people are has their own Hadoop, but architecture is the same. The HDFS and MapReduce, the architecture is same. Okay, let's move. We have already discussed about these things. So I want to show the cluster how it looks. Yeah. So this is how the real-time cluster looks. Like you'll be having the racks, and in the racks you'll be having a machines like this. These are called nodes. So which will contain the only three components. The components are like RAM, processor, and hard disk, and network. Network anyway it will be there because the machines are connected to each other in the, the racks. So each device, like here if you see the white color, each device will contain the RAM and processor and hard disk. Okay. And this is how it looks. The racks are looks like this, and when you look at the Hadoop cluster in the real time, it will be like this. I mean, it's real time in the sense they will be having a multiple racks, and in the each rack will be having a multiple nodes, right? There will be so many nodes, data node, and we will be having a name node, and we will be having a job tracker. The job tracker can be part of the name node, or it can be a separate machine. It can be a separate machine, or it can be part of the name node, and you can have a secondary name node or backup node, whatever we have discussed. And you will be having a dedicated client. Some people, they will be calling as edge node, right? We will be having the cluster like this, right? The cluster looks like this. So any doubt in this cluster? Anyone has any doubt here?
Yeah, Ravi, actually, as we can see that we have different racks,
Uh-huh.
and as you previously mentioned in one of the classes that if blocks are distributed, so if there are three blocks, then two blocks will go in one rack and one block will go in another rack. So if at all one whole rack goes down, then still we can read the data. Is that
Correct,
right?
correct.
Yeah. Now, are these all the rack will be there in only one data center or different? Because why I'm asking, because if in a particular data center, if there is fire or there are something, then all the racks will go down. So, is this possible that two different rack will have at different data centers?
Yeah, very good question. I mean, someone has asked the same question sometime before. See.
Actually, this question I was asked on this Friday in an interview, so that's why I'm
Okay.
asking.
So, okay, very good question. See, you will be having a two type of clusters. You will be having a two type of clusters. One is in-house cluster, another one is a cloud cluster. The cloud cluster is always will be with the either Amazon, Azure. We know that, right? The cloud cluster. The other cluster is in-house cluster. So in-house cluster means we will be creating our own cluster on our organization, right? So it means that your racks will be there in our organization only. So most of the scenarios, that's I'm taking the most of the scenarios, I'm not taking the rare scenarios. So most of the scenarios your racks will be in your single location only. Okay, so they can have a replicated cluster. There are replicated cluster. We'll talk more about the replicated cluster later. So you will be having all racks. If it is an in-house cluster, you can see your in-house cluster will be having a multiple racks in your same location. It doesn't mean that we cannot keep another rack in other location. It doesn't mean that. So you can also have that. So when you have a rack in different location, it's again a little burden on the network. So we are looking for the performance. We are looking for the fast access, right? So most of the cases, the all racks will be in the same location. Even if you go with the cloud also, most of the same racks will be in the same location. So when you're going to design your cluster, or when you're going to set up your cluster, we will be looking at all these cases, right? So where we'll be having a natural disasters, where we'll be having a more floods. So where we'll not be having that, in that location we'll be setting up the huge clusters. So that will be taken care before. If it's a natural disaster, everything is collapsed and everything is gone, so we can't do anything in that case. We will be losing it. Yep. Am I clear your answer, Dheeraj?
Yes, Ravi. Thank you.
Yeah. So this is how it looks. Now I'm going to discuss something about the policies what we were talking before, rack awareness, as well as what is the block placement policy. So we are going to discuss about now. So how the so when we are seeing the right operation, when we are seeing the right process, right flow, data writing into Hadoop flow, what we have discussed, the right flow, what we discussed, there will be a client, there will be a client who will talk to a name node, who will talk to the name node, and name node will fetch the missions, right? Name node will fetch the mission. This is what we have talked about, right? So based on some policy, what is it policy? The block placement policy and rack awareness policy, right? This is what we have discussed in the previous classes. So when the client when the client wants to write some data into HDFS, that data, the client will go and talk to name node, and name node will identify the missions based on the policy. The policy is the block placement policy. What is the block placement policy? So the block placement policy says that block placement policy and rack awareness says that. So just now we have seen the data will be there in the multiple racks, right? So when you are configuring your cluster, right, we will not configure in the cluster in the single rack. We never configure it. So it doesn't mean that it can't be allow. It will allow. It will allow. So but if what if the complete rack goes down, right? It doesn't mean that it will not allow. It will allow. You can go ahead and set up in the single rack, right? In one of the machine is name node. Let's assume that one of the machine is name node, rest of the machines are data nodes. Rest of the machines are data nodes. What the policy says that, so what the policy says that, let's say it's rack 1, it's a rack 2, it's a rack 3. As soon as the request come to a name node, as soon as the request come to name node from the client, let's say the client is here. Let's say the client is here. As soon as the client is requested name node for the storing the data, what your name node will do first, it will try to look for the data nodes. I mean, all the validations will go, guys, like whether the file is exist or not. Your name will look into whether the file is exist or not. If the file is already exist, it will fail the job. So all these validations will happen. So I'm talking about the successful scenario. So your name node will look for the missions who are near to the client. So always your name node will try to pick the missions who is near to the client, and those missions will be given the first priority. If there are missions but they are busy, or they are already about to full in the sense they are it has to be distributed manner, the data has to load, right? So if the machines are busy or the machines are so almost full, so what your name node will do, and it will go and choose some other missions. So while choosing the missions, what it will do, the policy rack awareness policy says that, what this rack awareness policy says that, select two missions. Let's say this is one mission, this is one mission, let's say it's a B1, B2, and select other block in different machine, or other different rack, not in the same rack. So the policy says that first look for the near, whoever are near to the client, to select those machines. If they know none of the machines are near to the client because they are already full, they are busy, or some operations, or I mean the machines are some they have already occupied some data. And what your name node will do, your name node will choose different machines from different racks. So can be in the same rack where the client is there, it can be other racks, right? So first what your name node will do, it will choose two machines from the rack, any of the rack, and one other block will be different. different machine it will choose. So why it is? Let's assume that one block goes down here. I have a backup in the same rack. If both the racks, complete rack is gone, so let it be I have another place where I have a same copy in other rack, same copy in other rack. So that is the reason your name node choose two blocks from one rack, two blocks from one rack. I mean two machines from one rack and other machine from other rack, other machine from other rack. So this is how your name node choose the machines, right? So here you may get a doubt why to choose two machines from the two racks. Anyway, I have multiple racks. Let's choose, no, let's choose one machine, one block here, one block here, one block here. Can't it be? It can be, right? So to answer that, so before that, to answer that question, before, let me ask one more question to for you guys. And there are some other experienced guys here. No, I know that some people are already known guys also join here. Let me ask a small question here. Why the default, why the replication factor, default replication factor 3? Why 3? Why can't it be 4? Why can't it be 2? Why can't it be 5? Can anyone answer?
Ravi, it is three because we have put two blocks in one rack. So if that rack goes down, then if we have replication factor as two, if that block goes down, then all the two blocks will be down. So we cannot have two, and we should not have four because that will be many number of blocks. So more data and more space is required. So we
So
cannot have four. I mean, we should not have four, so we should have in middle.
no, why can't I can't? I mean, I'm just trying to make you understand, guys. Why can't it be two? The case one, let's take. Why can't it be two? I'll store one block here. I'll store one block here. So now still I have a copy, right? To answer, I mean, to cross question you. I mean, it's cross question in the sense I'm just making you understand. So why can't it be two? I can choose one machine from one rack, and I can choose another copy from other rack. Can't it be possible? It's also possible. So why the default replication factor came 3? Because we have a block placement policy, rack awareness, saying that you have to choose two copies from the same rack. Why? So I'm going to answer for that. Why we need to choose, why two machines from same rack? Why two machines from the same rack? Let's take an example. Let's take an example. I have taken here machine 1. I have taken machine 2 here. So while I'm processing this machine, this block is corrupted. This block is corrupted. So I can easily go and get the data in this other machine from the same rack. If it is in other machine, like somewhere here, so what I have to do? So here I'll be having one switch, and here I'll be having one switch, here I'll be having one switch. So I need to talk to this, and I need to go here, I need to find it, and again I need to go here. So the way it will take the more communication, it will take the more time to communicate with that machine, right? So initially I have loaded the data here, or while loading or while processing the data, irrespective of it. While let's take while processing, okay, both are same. So while writing also same, while reading also same. So I'm taking scenarios while processing this machine. If this machine goes down, so other copy is there in this machine. I have to go across all this, then I have to talk it. So it may take some time. If it is in the same rack, another machine, I can directly go and fetch it in the same rack, where the inner communication between within the rack is more faster than communication between outside of the rack. The communication between the two machines within the rack is faster than the communication between outside the racks, right? Keeping that in mind, they have come up with the two blocks in the same rack, because even the one copy goes down, I can bring it another copy. And that is the case one. The case two is that there may be chances that there may be failure, or network failure or something, the complete rack can go down in this case. So in this case my job should not fail. I can go and fetch. Anyway something is bad happen, so in that, let's go and fetch the other block from other machine, other rack, and just process it. right? So you may ask that, so why can't it be 4? The next question is, why can't it be 4? So if I have third copy here, I'm going to keep a fourth copy. So my rack is failed, my job is about to fail. I can choose either this or either that. So I will go with the best available, right? Why should I go? So already I have a copy here which is available for me. So I will process here. Then why unnecessarily keeping one more copy here? The simple reason why the replication factor is 3, to satisfy your block placement policy, and rack awareness, keep 2 blocks in the same rack. If it is a 2, I have to keep both the blocks in the same rack. If I keep both the blocks in the same rack, there may be a chance rack can fail. So I cannot have a 2. The next case 3. So if I have a 3, 2 copies I'll keep in one rack, another copy will keep another rack. That's a well suit and best available, or best what you call, you can say best way to do it. Why? Because while I'm processing one machine goes down, I can fetch the same data from other machine, the same rack, where I can easily launch it. I don't need to go and talk to switch, and I don't need to go and get it from other machine, right? So the communication between the inner rack is faster. If something is went bad and complete rack is gone down, so I can't, there won't be any alternative. We have to go with outside the rack. So anyway, I'm going here, I'm getting the rate data. Why should I have another copy, fourth copy? So that is the reason the default replication factor come as a 3. The default replication factor has come as a 3. So, so the
So, Ravi,
yeah,
does it mean that while processing the data, when name node reads the data or client will read the data, first it will go to the rack where 2 blocks are there.
yes.
And if that rack fail, then it will go to, so it's not like, ideally it should have been based upon the distance, where the distance is less, but by default it will go where 2 blocks are there, right?
See, that's what they will check for the best suitable, right? So where 2 blocks are there, so it will try to launch in the same rack. There may be a chance other blocks also will be in the same rack, right? So if I choose this rack, let me
Yeah.
process in this rack only.
Okay. Mhm. Okay, all right.
Understand, guys?
Ravi,
Yeah,
one question.
yeah, Mit.
Let's take when we manually change the replication factor to 2,
Mm-hmm.
so both blocks will be stored in a single rack.
No, that time it will
Is it
move to one
correct?
one copy to another rack.
Okay, okay.
When we manually put it 2 copies, so
Hmm.
it will go to one copy other.
When it will be stored in a two different racks.
Yes.
Okay, okay. Thank you.
Any other doubts, guys? Okay, so here there are few guys who are asking, the basic questions. Maybe their first class it is. And what is a cluster? Can someone answer me what is a cluster?
It's a
Cluster
group
is
of
combination of, yes, sorry, please go ahead.
it's a group of data nodes.
A cluster is a
Nodes.
collection of machines who connected in the network and they act as a single machine. A group of machines who connected each other in the network and who act as a single machine. That's called a cluster. And there are some other questions. Let me go. What is a node? Can someone answer what is a node? A node is a physical machine which is connected in the network, who connects 2 points. Let's say I have a network, I have connected multiple machines. So to connect one machine to another machine, there will be one more machine in the center, like who connects machine. So node is not like in our normal, in the graphs you will be having a nodes, right? The terminology represent that. The node is a physical machine which is placed in the network who connects to multiple machines, or who connects to the single machine or multiple machine, and who serves the who provides the service to read or write, who provide the service. That's a node. Data locality. Can someone tell data locality? It's a very much important interview question, and because of the data locality only how to
So,
become famous.
while processing the data, the mapper job will go to various data nodes instead of data going to map task, like happens in typical system, like Oracle data goes to service layer
Yeah.
and their processing happens.
Yes. So guys, there are two terminologies we need to understand. One is a code locality, and other one is data locality. Code locality means you are moving your data towards the code, and code will be executing in this machine. Your data is coming towards towards your code, towards your algorithm. That is called code locality. Code is not moving anywhere. Your data is coming towards your data, towards your code. That is called code locality. When it comes to the data locality, your algorithm is going towards your data. Algorithm means your map, whatever the logic you have written, whatever the logic you have written, right? Your computation code. Some people will call it as a computation code. Your computation moving towards your data wherever the data resides. The moving data is a costly operation. That's why you are moving your code, because even though if you write a very big project, the whole project will be in 100 MB to 150 MB, 200 MB, very big project code I'm talking about. But the data can be in any size. So instead of moving whole data, you move your code towards the data and execute the data and execute there. That is called data localization. Moving computation towards a data is called data localization, instead of moving data towards computation. Yep, these are the questions has been raised in chat window. So do you guys have any questions? Please go ahead.
Yeah, Ravi, actually I couldn't understand in traditional way how data is, I mean, what's the difference in traditional system and big data regarding this data locality?
Akash, we already discussed about this in some of the videos. So I mean, I would recommend you to go through once, please. And still, if
Okay.
you have a doubt, we can discuss it. Okay. And
Yeah.
let's give a chance to new guys who wants to ask a new other questions. Repeat instead of repeated questions.
Ravi, sorry, I have a question again.
Hmm.
So, like rack awareness system, I understood that block will be stored in two different racks. So, same is the case with the name node also. If we have two name node like active and inactive name node, those two name node will be in different racks, right?
Correct.
Yeah, that's what I wanted to ask.
Correct. It will be
Those
the
two has to. Yeah, okay. And like, what if the general node goes down?
sorry.
If like general node goes down, then
So they will be having a local copy in the standby name node, right? The standby name node is the person who is merging the your FS image and edit log, and your
okay,
standby name node
okay,
anyway it has a copy.
yeah, okay, okay,
So guys, the failing the this name node, secondary name node, these zonal nodes are not that much easy. Data nodes may fail because the data nodes are the commodity hardware, where your name node and the single point of failure nodes will be good amount of, I mean, good nodes. I can say good machines, good configuration machines. Yeah. Any other questions, guys?
I mean, how the, like, let's say we are about to write the data into the block. So how, on which algorithm the block will be placed into the node? Like any particular algorithm, or how it will be placed?
Could you please repeat your questions, Raven?
Like let's say I'm writing one data to
Mm-hmm.
my, I'm writing one data. So how the data will be copied to the node? Let's say I have multiple nodes. So on which algorithm it will copy the node? Like, is it like a shortest path, or like
Yes, it is the
based
shortest path.
on the server available?
It's the shortest path.
Okay.
The first is the shortest path. Like your name node will choose who is near to the client. So choosing who is near to the client means the data is there into the client, right? So client is going to write the data, not name node. So many people has a doubt. So there so many people are thinking that our name node will write the data into data nodes. No, your client will write the data into data nodes. So it means that the data node should be near to the client, not to the near to the name node. So the client is the person, or the client is the machine who is going to connect to the data nodes and who is going to transfer the data towards a network. Who will create a data pipeline, or instead of saying data pipeline, I can say data stream, where you can transfer the data in the form of packets.
Understood.
Right?
Thanks.
Yeah.
Yeah.
Pasha, yes, I'll give you a link. 1 second. Any other questions, guys?
Hi Veera.
Yeah.
How to monitor the cluster
Okay,
in
so
Cloudera
for monitoring the clusters,
after
we
setup?
have to monitor the cluster. We have monitoring tools. Like you have so many tools. Like if you want to monitor from Hortonworks, you have Ambari, and if you want to monitor from the Cloudera, you have a Cloudera manager, and there is one more thing called Cloudera Express, and there is
Okay.
something called Cloudera Navigator. So where you can do from there.
Okay. If you see in our old clusters, we are using Ganglio and
Gangilio, correct.
Nagios.
Nagios, yes.
Ganglio.
Yeah.
Will it integrated to Cloudera? Cloudera distributors?
Nagios,
Yes.
yes, we can do it. I mean, I'm not really sure about the administration part, so I'm not have that much great hands-on in the administration part. So, if
Okay.
you really need that information, yes, I can. I can get you some information by talking to my this guy's administration people.
Okay. I know in Ambari we have Ambari metrics and
Yeah, in Ambari you'll
old
be seeing number
clusters
metrics, correct.
yeah, before 1.4 will integrated Nagios, then latest 2.4 onwards we don't have Nagios, so
Okay,
they designed like Ambari matrix so that they will
so they can see
see
the here
the
only, yes,
metric.
monitoring, yes.
Yeah.
And Aditya, coming to your question, computation process is handled by job tracker. Yes, the computation handled by job tracker means your job tracker takes the your job tracker will take the job request and it will create a job ID. There will be a scheduler who will schedule the job, and your job tracker will tell to the task trackers who is the slaves to the job tracker, and they will start launch the data and the job into those data nodes, respective data nodes. If one of the rack does not have a two blocks available to store data, can the block be stored in different racks, which will be which is violating Rackwareness? If one of the another question, guys, I'm going to read out here. If none of the rack does not have a two blocks available to store data, can be the blocks be stored in a different rack, which is violating. I mean, none of the racks does not have a two blocks. What does it mean, Sanchari? I mean, I didn't get it. Could you please unmute and talk? I would like to understand the question in better way.
Yeah, hi. Yeah, hi Viraj, Sanchari here.
Yeah, tell me, Sanchari. Yeah.
Yeah,
Could you please tell me what is your question? I mean, I really didn't get your question. Okay, I think some network issue.
in one same rack. Suppose the rack, one rack, all nodes are filled. Okay, so only there is suppose one block is left to store a data and no other blocks is left in a particular rack. So what it will do? Like
Okay.
I'm just thinking of some hypothetical case, like all the racks having data nodes and having only one block is empty to store the data.
I mean, one machine is empty
So
to store the data.
will it validate the rule or?
Okay, okay, guys. What I have understand from her question,
Yes,
she is
yes.
telling
For
that.
all the racks, I'm just
So
thinking of assuming.
the cluster is full. Her question is that the racks are full. There is only one rack. There is only one rack. That rack has a free. There in that rack there is only one machine. Right? How it will store? So that kind of situation never comes in the Hadoop. So that kind of situation never comes in the Hadoop. We already talked about something called balancing, rebalancing, where you will be having you will be set the threshold. So as soon as this is reaching to the threshold, your admin will be keep monitoring it. So what is the how much space is left, what is the occupied data, what are the what is the assigned space and how much has been occupied. So your administrator will be keep monitoring it. It never occurs the scenario. If it occurs also, so it is really happy to load one copy. It is really happy to load one copy because we have something called minimum replication factor. There is something called min replication factor we have discussed sometime before. There is a min replication factor 1. So if it's able to copy one copy, it's really happy. Yes, it is violating rack awareness, but later when the clusters, the more nodes are available, it will again what to say, when you run the balancing, you can again it will copy into other missions. That can be possible. Sanchari, am I answered your question? Okay, so guys, tomorrow we need to do a setup. Tomorrow onwards we'll be discussing about some commands. Okay, so we'll be discussing some commands from tomorrow, and I would request you to if your missions are ready, you guys can have a setup in your missions by going through this where is the list we have, where we have a setup, Hadoop setup and Ubuntu missions. So here you have how to install Ubuntu in your Windows machine, how to install your Ubuntu in Windows machine. There is steps here, and how to install Hadoop in this. So you can follow either of this. I hope I'll feel this is good. Before second video, follow the second video to install your Hadoop, and I'll be sharing you a document in the my GitHub. And go to GitHub and search for the Veera Ravi. So you can find my repository, or you can say my Git.
Ravi, actually, I have downloaded the Cloudera Quick Start. So is that okay, or
Yes,
do I need to follow this
that's
only?
also okay. No problem. That's also okay. So you have downloaded Kickstart,
Okay.
right?
Yeah,
Yeah,
Cloudera. Yeah.
yeah, that's also fine. Yeah, so okay, and also coming to communication channels between your nodes, we already discussed about it. So the data node to data node, it is HTTP, and client to name node, it is a RPC, and data node to name node is a RPC, and client to data node is the HTTP. Okay, here someone has some doubt. What is the minimum RAM required for? So Lakshmi, if you are going to install Ubuntu in your machine, if you have a 4 GB RAM, if it's a 4 GB more than that, I will recommend you to go for VirtualBox. Lakshmi, if you have a 4 GB or more than that, I recommend you to go with the VirtualBox. Okay, and a VirtualBox comes like this. Oracle VirtualBox, it comes like this, where you can install your Ubuntu. So the steps which I have given for VirtualBox only. The steps which I have given in the YouTube channel, those are for VirtualBox. If you have a more than if you have less than 4 GB RAM, if you have a less than 4 GB RAM, I request you go. I request you for go for dual boot. Get it done the dual boot. You go and get it done the dual boot. And yes, 8 GB RAM is sufficient. You can go with VirtualBox. You can install Ubuntu. You can install Hadoop on it. We can do a hands-on in it. Really, it's really sufficient 8 GB RAM.
Okay. Okay. Thank you.